This is a recording of the first part of the 6-1 section lectures, where we start talking about random variables. We start with a definition that a random variable takes on numerical values to describe the outcomes of some chance process. Let me say it again. Essentially, it's a situation where the outcome can't be known ahead of time. It's random, unpredictable, and the outcome must be some sort of numerical value. We said that the probability distribution of a random variable gives all the possible values that the random variable takes on, paired with their probabilities. So let's talk about a situation where that may happen. Let's say we toss a coin 3 times. What's the sample space for this? Well, the sample space is that we might get all tails. Let's try that again. All right. Or maybe we get 2 tails and a head, but that can happen 3 different ways. It's going to have to be a head and then a tail and a tail. Maybe we get a tail and 2 heads, and there's 3 different ways for that to happen. Or maybe we get all 3 heads. There's the sample space. Now, that sample space doesn't have any numerical values. There are 8 equally likely outcomes, so the probability for any one of these 8 things in the sample space is 1/8. But now let's turn it into a random variable. Let's say we take a look at this and say, oh, we're going to count up the number of heads obtained. We look at this outcome, and there's one outcome for which the random variable has the value 0. Or maybe there's the 3 outcomes where the random variable takes on the value 1, the 3 outcomes in which there's exactly 1 head, or the 3 outcomes where the random variable takes on the value 2, or maybe the 1 outcome where the random variable takes on the value 3. So we think about the values that the random variable takes on, in this case from 0 to 3, and we think about the probability associated with each of those outcomes. That's a probability model. All the possible values that the random variable takes on and the probability associated with those random variables. And with this model, we might ask, well, what's the probability that the random variable is greater than or equal to 1? Well, that's the probability that the random variable is exactly 1, plus the random variable is exactly 2, plus the probability that the random variable is exactly 3, or 3/8 plus 3/8 plus 1/8, or 7/8. And because all 3 of those outcomes are mutually exclusive, we can simply just add up those probabilities. There are 2 kinds of random variables: discrete random variables and continuous random variables. We're going to focus on discrete random variables. So what makes a random variable discrete? The fact that the random variable takes on a fixed set of values with gaps in between. So in the previous example, 1, 2, 0, 1, 2, 3 were the outcomes, and there's a gap between 0 and 1. Like for example, 0.5 or 0.75, not in the list. There's gaps in between. Now, when we have a discrete random variable, please note that the sum of all of the probabilities must be equal to 1. It must be a valid probability um, distribution. And remember that, as with what we talked about in the previous chapter, that each of the probabilities has to be some number between 0 and 1. For example, in 2010, there were 1,319 games played in the National Hockey League's regular season. Imagine selecting one of these games at random and then randomly selecting one of the two teams that played in the game. Let's define X as the number of goals scored by one of the randomly selected teams from a randomly selected game. Here's the probability distribution of that random variable X. Sometimes teams score 0 goals, sometimes they score 9 goals, and then all of these in between. This is a discrete random variable in that there are gaps in between. How would we show that this probability distribution is legitimate? Well, we'd ask, well, what's the probability of the sample space? Well, it would be 0.61 plus 0.154 plus, oops, 0.228 plus 0.229 plus 0.173 plus 0.094 plus 0.041 plus 0.015 plus 0.004 plus 0.001. Now, when we add up those numbers, do we get 1? Well, let's start with the thousands digits. 1 plus 4 is 5, plus another 5 is 10, 11. 11 plus 4 is 15, 18. 18 plus 9 is 27. 27 plus 8 is 35. 35 plus 4 is 39, plus 1 is 40. That's a 0, and I'm going to carry the 4. 4 plus 1 is 5, plus 4 is 9, plus 9 is 18, plus 7 is 25, 27, 28, 28, plus 3 is 31, plus 6 is 9. I must have screwed up someplace here. 4, 1, 5, plus another 4 is 9, 18, 18, 25, 27, 29, 29 plus 4, 34 plus is another 0, carry the 4, 4, 5, 6, 7, 8, 9, 10. There we go. And there we go. It is equal to, the probability of the sample space is equal to 1. Therefore, this is a valid probability distribution. Make a histogram of the probability distribution. Describe what you see. Okay, well, I'm going to break up my horizontal axis, making each bar too big. 1, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's all of the different values that the random variable takes on. And I think if I break this down in 0.4, I think I'll have enough space. Oops. Let's try that one more time. 0.04, 0.08, 0.12, 0.16, 0.20, 0.24, and the largest number I have is 0.229, so I think we're okay. And then let's start making the bars. This one's going to be about 6% big. Second one is going to be about 15% big. That's about here. The next one after that is 22% big, so about here. And then another about 22%. Actually, close to 20. Both of these should be close to 23%. So let's make them just a little bit higher. And then we go to 4, about 17%, which is about there. And then 9%, which is about there. 4% out here. 1.5% out here. And then we're getting down to almost nothing. What do we see? Oh, what do we see? Describe the distribution. We're back to socks. How about the shape? The shape of the distribution of NHS schools, NHS, NHL, appears to be skew right. Okay, I'm gonna not question about the outliers, although I think probably 6, 7, um, well, certainly 7, 8, and 9 appear to be outliers, but I'm not going to do the calculations for that. The center, probably we should look at the median. The median, 6% plus 15% is 21%, plus another 23%, gets us up in the high 40s. It looks like the median is 3 goals. That's the first value that gets us over the 50% threshold. And then spread, how about the range? The range is 9 minus 0, which is 9 goals. And there we have it. There's a quick refresher about describing a distribution. What's the probability that the number of goals scored by a randomly selected team is at least 6? Well, let me write that down. What's the probability that our random variable is greater than or equal to 6? Well, these are, again, non-overlapping outcomes. So how about we say probability of 6 plus the probability that x is 7 plus the probability that x is 8 plus the probability that x is 9 ends up being 4.1% plus 1.5% plus 0.4% plus 0.1%. And let's see if I can do this. 1 plus 4 is 5, 10, 11. Carry the 1. 1 plus 1 is 2, is 6, and no carry. So how about the probability is 6.1%. And that concludes our 611 lecture.